Alright, so busting out another one today. So, we're going to talk about assessing risk today. As you know, most things in life we do is not a 1 in 10 chance of dying most of the time. Most things that we do. 1 in 6 people are not affected with some disease. 1 in 8 people don't get run over by cars driving down the street. Usually the chances of these things happening are minuscule. It's like 1 in some ridiculously teeny tiny amount. So if a person said, listen, I would like to see it as a percentage, well, 1 out of 6 is about 16%. Okay? And 1 out of 100, of course, is 1%. That's easy. What if it's 1 in 260 million? Well, 1 in 260 million is a teeny tiny percent. One that we could actually figure out if we opened up our calculator. Again, I don't know why I keep closing that stupid thing today. Not that button. There we go. So if you want to do it, you go 1 divided by 260. 1, 2, 3. 1, 2, 3. Is that teeny tiny number? And you say, all right, times it by, not divided by, times it by 100. Oops. And that would be your percentage, 0.0000003, right? That would be the percent. Well, that's ridiculous. 0.0000003% chance of something happening. That doesn't even make sense to me. It's so small, I can't really fathom it. And so what a lot of times we'll do is this. When we see a percentage that's this small, we will take it and rewrite it so that it is a whole number, one whole number, out of however big we need to make it happen. Okay? And so a lot of times you'll hear this when it comes to infectious diseases. 1 person in 220,000 people have this disease. Okay? Or 1 in 3 million people have this particular ailment, whatever it happens to be. When I see this, that is pretty rare. This isn't as rare. This is really rare. It's kind of a big deal. And so you think about it like that, it makes sense to us. So that is what this section is going to be about. It's going to be looking at some statistics that they've given us and then trying to position it in a way that makes more sense to you. So if you're following along, here's one that has an example. It says that, I'm going to pause for a second and write the table here for us so we can all look at it. All right, there we go. And so we can make a bunch of different rates here. So this is in 1995. There were 263 million Americans. There was 41,817 traffic fatalities. There's 177 million drivers. And those drivers drove 2.4 trillion miles that year. So in 2010, we want the fatality rate per 100 million vehicle miles traveled. So I want the fatality rate. Let's just find the fatality rate first. So there were 41,817 deaths in 2,400,000 billion rather. So that's trillions, billions, millions, thousands, on down, yes? That's 2.4 trillion. Now, if you stop and think about that for a minute, I can divide this out. 41817 divided by 2400. And I get this teeny, I get this teeny tiny answer. Okay? And it's so small that I can't even really read the thing. Okay? That is 0.0000001 deaths per mile. Well, doesn't even make sense. I would like to know how many deaths it is so that I can get it up to where, because currently it is 0.0000017 deaths per 1 mile. And what I would like to do is I'd like to get that numerator was a whole number. I would like this to be a whole number on top, because that small of a number of deaths makes no sense to me. Okay? Well, in order to do that, I'm going to have to move the decimal over 1, 2, 3, 4, 5, 6, 7, 8 places to make that happen. So it's going to be 1.7 deaths. Now, in order to do that, I had to multiply by 10 to the 8th. Yes? And if I multiply by 10 to the 8th on the bottom as well, what is 10 to the 8th? Well, son of a gun, it's 100 million. So there are 1.7 deaths for every 100 million miles traveled. And that's why your book suggests on that problem why you should do it per 100 million. Because I want to get a whole number of deaths on top. And to do that, I need to move it over 8 places. Okay? Oops. Now, let's do the next one here. It says, express the 2010 fatality rate in deaths per 100,000 of the population. But let's look at fatality rate per population. Let's just do it this way first, okay? So fatality rate, and so 32,885. 32,885 divided by 309 million. Okay? Again with the calculator. Is 0.0001, right? 0.0001. 0.000106. Okay, now, in order to actually make this, to make it make sense, I need to move it 1, 2, 3, 4. So 1.06 deaths per. Now, I multiplied it by 10 to the 4th. Well, what is 10 to the 4th? That's 10,000, okay? 10,000 what? People, okay? So there's 1.06 deaths per 10,000 people. Now, your book suggested I do it per 100,000. Well, if I want to do it per 100,000, okay, that should be 10,000 on my glasses on. So if I want to do it for 100,000, I need to multiply the bottom by 10. I need to multiply the top by 10 as well. So I'm going to have 10.6 deaths per 100,000 population. Okay? Simple as that. Okay? Simple as that. 1, 2, 3. Yep, looks good to me. All right. And another one here. Let's do deaths per licensed drivers. Let's do in the year 2000. Let's want deaths per licensed driver in 2000. So there was 41,945 divided by 190 million licensed drivers. And let's see what this comes out to be. So it's going to be 41,945 divided by 190. So 0.0001. That's deaths per one licensed driver. Well, that didn't really make any sense to me, so I'm going to kick it over 1, 2, 3, 4 places. So I'm going to multiply by 10 to the 4th, which is 10,000. Okay, so in other words, I'm going to have 2.21 deaths per 10,000 licensed drivers. Now, a person could argue and say, well, could you make it per 100,000? I'm sure you could. So it's going to be 220 or 22.1 deaths. 22.1 deaths per 100,000 drivers. Or 221 divided by 1,000,000 licensed drivers, right? So all we're doing is we're just changing what our denominator looks like. It's pretty easy to do in that regard. Okay? Yeah, here is another piece of information for you. You may not know this. There were 84,700 deaths from Alzheimer's. And this was in 2011. Okay? Now, I didn't make that up. It's right there in the book. There you go. Now, in 2011, there were 315 million Americans. Okay? So give me a rate that actually makes sense. Okay? So when you look at it, well, that's 84,700 divided by this. Let's reduce it down to where it makes sense to us. So I divide it off. That part's pretty straightforward. 84. All right, right there. So 0.000269. Okay, and that is deaths per person, per one person. Okay, 1, 2, 3, 4. So there are 2.69 deaths per 10,000 people, right? Or 26.9 deaths per 100,000 people, or 269 deaths per million people. Any of those are totally fine. Okay, and any of them are perfectly accurate, nothing wrong with either of them. Now, let's compare that to something else. Where else could we have deaths from? Now, clearly, a person that has to be a brain-dead idiot not to understand that that the one about flu and pneumonia is 53,700,000 or 53,700. Well, obviously, you're more likely to die from Alzheimer's than you are from the flu or pneumonia. Clearly, any idiot can see that, because this is clearly a bigger number. However, we can also express this as a rate per thousand or million or whatever we want. So 53,700 .0002317. So 1.7 per 10,000, 17 per 100,000. Or 170 per million. Okay? This is bigger than this. This is bigger than that. This is bigger than this. This is bigger than that. No matter how you phrase it, you're more likely to die of Alzheimer's in 2011 than you were of the flu and pneumonia. So I always think it's hilarious because they always make it out like the flu is some huge, horrible thing, which it is if you have a low, compromised immune system or something. But yeah, you're way more likely to die of Alzheimer's. It's really not even close. Okay? So that is the idea with Section 7D. Is really just the idea of looking at it in terms of how does that work out for you. Okay? So, excuse me. That's basically the idea of that there. Here's another good problem for you. So suppose a life insurance company issues, it insures 5,000 people that are 40-year-old and their rate of death are 3 per 1,000. So we're going to insure 5,000 people. And you have 3 deaths per 1,000. Okay? So right off the bat, how many people are you expecting to die? Well, you can write it out like this, is how I would do it. Times 3 deaths per 1,000 people. Cancel the people. 1,000 goes into 5,000 5 times. You would be expecting 15 deaths. In other words, you'd be paying on 15 people. Okay? If the premium costs $200 per year and the death benefit is $50,000, how much can the company expect to make or lose? Well, if it's 5,000 people and they're each paying in $200, okay, that's how much the company is going to be bringing in. they're going to be bringing in that much money. But, which is 1, 2, 3, 4, 5, 6, $1 million. Okay, but they expect to pay out 50 grand. So per death. So 50 grand times 15 is 700 is 750,000, right? And so if you do this minus this, the company should expect to make $250,000 that year. Okay, that's how that goes. Again, all based on expected values. Okay? That's why it's in this chapter, is because it's all about probability. Okay?